This is a Sutotal production. Hello surveyors. Alright, so this is going to be our second practice video for chapter 4. Here we're looking at ionic naming, and there's kind of two categories of ionic naming. This first one is going to be with monoatomics, so there's no polyatomic ions present. So this is really just stuff straight off of the symbols that we see as our anions and or our cations. All right. So here we have Na and an N. So what we see here is sodium, based off their placement on the periodic table, right? Everything in column 1 tends to have a +1 charge. Everything in column 2 has a +2. Everything in this third column here tends to have a +3. This carbon column can fluctuate between positive and -4. But then here, this nitrogen-based column here, this is going to be -3. This oxygen column is -2, and this fluorine column is -1. So, I mean, the sodiums are all +1, and then this nitrogen is a -3. So it does make sense that there's 3 sodium ions for every 1 nitrogen ion. But the name of this, because this metal is not a transition metal, we just named the cation, this positively charged thing, we name it exactly how it is on the periodic table. So this is called sodium. All right, now this is nitrogen, but your anions, you take the ending off of their name and you replace it with "ide." So this would be sodium nitride. So of nitrogen, I'm taking off the ogen, right? So sodium nitride. Here we've got another metal that's not transition metal. This is magnesium, and it's got a 2+. And then remember the fluorine column, all of those have a -1, right? When in their ionic ionic charges. So here it pretty much is the cation. We name it how it is on the periodic table. So this is magnesium, and then fluorine turns into fluoride. Right? And so the thing I want you to notice here, right, with ionic naming, we don't worry about the numbers here, right? So this didn't become like trisodium. This didn't become difluoride, right? We don't do that in ionic naming. That's in covalent naming, and that'll come later, okay? Next up, we have Cr2s3. So Cr, that's chromium, right? That's this guy right here. It's a transition metal. So for chromium, I'm going to need, because it's transition, I'm going to need a parentheses here where it specifies the charge on the chromium ion. So how do we get that? Well, the sulfur here is in the second column. It's -2. Right, and so that would be called sulfide, right? Sulfide. Now, with the -2, what do we have? We have -2 times 3. That gives a total of -6 on this side. Now, 2 chromiums have to equal +6 because overall it's got to be neutral. So we have 2 times our chromium equals +6. So that means the chromium has to be +3. So that +3 charge I denote right here with the Roman numeral 3 in parentheses. All right, next up we have AlBr3. So now we have aluminum. That's our metal, and it's our cation, and it's not a transition metal. So we just write aluminum, right? And I don't have to worry about the charge. And this Br3, so I just write bromide. All right. Now remember, the charges here do tend to be +3, and then over here the charges tend to be -1. Okay, so +3, -1. That makes sense. That's why there's 3 bromines. All right, next up we have K2O. So K, that is over here. So it's not a transition metal, and K is the symbol for potassium. All right. And then potassium, that ion tends to be +1 because it's in the first column. Oxygen's over here, right? And that tends to be -2. So that also explains why there's 2 potassiums, right? So oxygen, remember, we take off the end and we put "ide" in its place. So this would be potassium oxide. All right. Next up, we have sodium carbide. Sodium is Na, right? So Na, and that tends to be a +1 charge. Carbide is carbon. Now in this case, carbide is with sodium, so that's going to act like an anion, a negative charge. So the charge on that, based off of here, would be -4. So -4 + 1. So what does that mean? That means we should have Na4C. There should be 4 sodiums for every 1 carbon. Next up, we have lithium phosphide. So lithium right here is a +1. So you have lithium +1. And then we have phosphide, which is right here. And that's, remember, that's, what is that? This is the -3 column. So when we look, right, -3 + 1, that means there's going to have to be 3 lithiums for every 1 phosphorus. So it's going to be Li3P. So that would be our lithium phosphide. All right, manganese 3 chloride. So that 3 is telling us the charge on our transition metal, manganese, right here, Mn. So we know it's Mn3+. And we know that we have chloride, which is chlorine, right here. So chlorine is, based off where it's at in the column, that's a -1 column. So we should see 1 manganese, right, for a +3. And so this needs to be a total of -3. So there should be 3 of them. So it should be MnCl3. Next we have calcium iodide. Calcium, let me scoot it up a little bit more. Calcium is in this second row here. So calcium is a +2. And then iodide is right here in the same column as fluorine. So that would be I-. All right, now we have to balance the charges, remember? So there's a +2 calcium, a -1 iodide. So that means we need to have more iodides than we have calciums. So it should be calcium iodide like so. Two of those iodide ions, right? That would give us +2 -2 = 0. Now we have beryllium fluoride. Beryllium is in the same column as calcium, so that's Be, 2+, and then fluoride is in the same column as iodide, so it's F-. So we're seeing a similar scenario, right? A +2 cation, a -1 anion, and so that means we should see something very similar to calcium iodide. It should be BeF2. All right. So hopefully in this, when you have the actual formula, it's kind of easy to get the name part. You just got to remember the Roman numeral if you have a transition metal. But it does get a little bit harder if you're given the name, because the name doesn't necessarily tell you the formula, right? This name didn't tell you that you had 4 sodiums. This name didn't tell you that you had 3 lithiums. This name didn't necessarily tell you that you had 3 chlorides, right? So you want to make sure that you are comfortable with this practice. All right. Until next time, adios.